Alright, in this video we're going to go through how to do moving averages in Excel, and then we're going to use those values we calculate with the moving averages to go through how to do our measures of forecast accuracy, our root mean square error, our mean absolute deviation, and our mean absolute percentage error. Those are kind of three main ones used. So let's start off with, before we get going, let me just quickly say that if you want to follow along with this, you can download the Excel, this Excel spreadsheet probably from the Blackboard site. Go through on the frameworks tab. Complete solutions what we're going to do are in the complete tab, so you can go through, you can see all formulas and how we calculated everything. Alright, if you learn better that way. But let's start off with calculating moving averages. We're just going to do moving average with 4-period moving average. Start off with that. We're just going to use a simple average function, and remember we're going to average the 4 preceding values. If we were to include 48, that would be wrong, because we're using the 4 preceding values to calculate our forecast for time 5 over here. So the average of 32, 40, 26, 27 gives us our forecast for time 5. And we can copy that value down, and beautiful. So now we have a forecast for time 16, which is just the average of times 12 to 15. Okay, then we can use that value to calculate our measures of forecast accuracy. We don't have to do that. As you can see, the formulas we're going to use have updated already just with these values. We don't have to calculate residuals. You can do all these formulas without calculating residuals. But I'm going to calculate the residuals all the same, just because it can be helpful to just do it like that. I'm going to copy down the residuals just so you can sort of see where we're going, and this kind of shows us how far off each of our forecasts were. So let's go through the formulas for each of these root mean square errors. So let's start with the root mean square error formula. Okay, and we're going to try to get to this 20.29 number here. I'm going to show you how to do it. Okay, so for the root mean square error, and we're focusing on moving average of time 4, there's the actual formula is basically just we're going to calculate the mean square error and take the square root of it. The mean square error is the actual minus expected minus the forecast squared, sum those up, times n. Okay, so we can do that using, we're going to start off with we're going to have to take a square root of the whole thing, and we're going to take a square root of, or we're actually going to use the sum product formula here. Now the sum product formula is pretty cool in that it allows us to do arrays. Alright, it allows us to give an array of values, and we can perform a value in that. So what we're going to do is it's basically the residuals squared. So we're going to put the residuals in as our first array, the residuals in as our second array, and that'll sum the product of each of these. So it'll sum the residuals squared basically, which is pretty cool. At least I think it's pretty cool. And then we're going to divide that whole sum product by basically the number of residuals we have, which is this number here. I can see that gets us to our 20.29 number over there. Now you can see the way I did it so that we don't have to use the residuals is, instead of doing the sum product and the actual residuals, I went and calculated the residuals within the actual sum product formula. So you can do that if you want to. Just make sure that your count value is on the number of forecasts minus 1. So that works as well. So let's look at the mean absolute deviation formula. We can do the same thing. We're using the sum product formula to be able to work over an array. And let's kind of work through that quickly. So the mean absolute deviation, it takes the sum product. We give it an array of numbers. We're just giving it one array of numbers over here, so it doesn't multiply anything. It just sort of sums those up, and we can perform an operation on that array. And then we're going to divide it by the count. And just, if you've never heard the word array before, basically an array is just a list of numbers. And your sum product, or array, is going to be the absolute value of our residuals, right? So in this formula here, I didn't use the actual residuals, I calculated the residuals within the formula. So absolute value of all of those, and then we're going to divide it by, divide that by the number of residuals. There we go. and that gives us our mean absolute deviation. And then to calculate our mean absolute percentage error, I'm going to do something sort of similar to what we've been doing. Once again, let's look at the formula over here. Once again, we're using the sum product formula to be able to work over an array of numbers, but we do, instead of doing the absolute value of just the residuals, we're doing the absolute value of the percentage difference of the residuals, and then doing the same thing of averaging them. So we're going to say sum product, I'm going to say, and then our array is going to be absolute value of our residuals over here divided by the corresponding absolute values, so what kind of percent are we off by, and then we're going to divide that whole thing by the number of residuals, and that gives us a number, and then we just want to times that by 100 to get a percent. So that's how you get your measures of forecast accuracy. Once again, I recommend looking at the complete tab. You can see I've gone through it for moving averages of 2, 3, 4, 5, all of those, and you can kind of work through it and get some practice, because it definitely makes it a lot quicker if you can get comfortable with these formulas.